Okay, good morning, everyone. Good afternoon, as the case may be. What we're going to do now is we're going to briefly review another question like the previous two we did. It's going to be slightly different because, as I've said before, when we have questions of this nature, it's very rare that everything will be exactly as we expect, especially as we move closer to real life. The key is not necessarily following the same exact process every time, but learning to adapt the questions we're given to mathematical examples that we're able to solve using algebraic transformations and other algebraic tools. So let's begin. Let's quickly review the question we're looking at. This is our third practice example. Moore's Meatpacking Company produces a hot dog mixture in 1,000-pound batches. The mixture contains two ingredients, chicken and beef. The cost per pound of each of these ingredients is as follows. Chicken is $3 a pound, and we see that here. Beef is $5 a pound. Each batch requires at least 500 pounds of chicken and at least 200 pounds of beef. Also, the ratio of chicken to beef must also be at least 2 to 1. So this is a relatively simple question, but it's phrased and the setup is slightly different than what we've done before. So as always, let's go in and let's find the key information. Moore's Meatpacking Company produces a hot dog mixture in 1,000-pound batches. Is this relevant? In this situation, it is not. It doesn't matter how big the batches are. It's not really relevant to limiting us in any way. So we just skip over that section. The next section, the mixture contains two ingredients, chicken and beef. Most likely, this is going to be important and probably will be our decision variable. The cost per pound of each of these ingredients is as follows. Chicken, $3. Beef, $5. And so what we've done now is we have our decision variables. We also have the costs associated with those variables. We see here, now we can put together our objective function. We're relating the decisions we're making to the costs associated with the problem. So continuing on, each batch requires at least 500 pounds of chicken. If it requires, that is a limitation or a rule or a necessity. This is something that we cannot ignore. So that is clearly a constraint. It also requires at least 200 pounds of beef. So again, we see here that we have a limitation. If it is less than 500 pounds of chicken, it's not possible. If it's less than 200 pounds of beef, it's not possible. Finally, we have a third limitation. The ratio of chicken to beef must be at least 2 to 1. So here again, we see a limitation, something guiding us, forcing us to make choices based on what we anticipate as being necessary. So see, we have our decision variables, our objective function, our constraints. And now we've completed our 3 steps necessary in problem formulation. So let's go to the next page and write down our 3 key steps. Decision variables. And as always, we're going to represent them as x1 and x2. We go back, and now we see that our objective function, and if we recall correctly, the objective function is when we have our decision variables, chicken and beef, and we're relating them to our ultimate goal. Now in this question, we see that it doesn't really tell us yet if we're minimizing or maximizing, what our goal is. So in this situation, we have to use a little common sense. If we're manufacturing, if we're making something, in this situation, we're producing a hot dog mixture, so we are manufacturing. In this situation, because we are manufacturing, we know that it is a minimization. When we are producing something, do we want to spend more money? If we're a company looking to profit, do I want to spend as much money as possible manufacturing or as little money as possible manufacturing? In this situation, I want to spend as little money as possible. So this becomes a minimization. A minimization relating our decision variables, chicken and beef, to cost, $3 and $5. So we go to our next page again, and for our objective function, min z, which is cost, is equal to 3x1, which is the cost for chicken, plus 5x2, which is the cost for beef. So now we have our decision variables and we have our objective function. The third and critical point, to go back, is to write our constraints, our limitations. Now these constraints are slightly different than we've seen before. So the first one, we require at least 500 pounds of chicken. It looks different because we haven't seen anything like this, but it's very, very simple. What represents chicken in this situation? Chicken is represented by x1. So x1 must be greater than or equal to 500. If it's not greater than 500, if it's not 500, this problem doesn't work because we don't have the requisite amount for our batch. So very simply, our first constraint, x1, must be greater than or equal to 500. And that's the minimum amount of chicken per batch. We go back and we see that at least 200 pounds of beef is also required. So one more time, we look in and we go up here and we see that x2, which is beef, must be greater than or equal to 200. If x2 is less than 200, very simply, we cannot continue. If x2 is less than 200, very simply, we do not have enough beef in our 1,000-pound batch. And that does not enable us to make that choice. So second constraint, x2 is greater than or equal to 200. And that is the minimum amount of beef per batch. So finally, x3, because we see here, or not x3, constraint 3, we see here there's a third constraint, a third limitation, and it says the ratio of chicken to beef. So x1 to x2 must be at least 2 to 1. Now again, this is something we haven't seen prior. And sometimes with constraints, we're in a situation where there are multiple ways to write in the constraint. But for simplicity's sake, we're just going to go with a simple way to write this in. If chicken must be 2 times more than beef, very simply, we make our ratio 2x1, which is 2 units of chicken, must be greater than or equal to x2, 1 unit of beef. So 2x1 must be greater than or equal to x2. We write in our constraint number 3. Greater than or equal to x1. And that is the ratio of chicken per batch to beef per batch. So what we've done here is as before, our constraints were slightly different than we're used to, but when we apply rational thinking and logic to the situation, we're able relatively simply to convert our natural language question to mathematical formulae that will allow us to solve and determine our values for x1 and x2, our decision variables. So the final step here for practice question 3 is to collect all of the relevant information in one place in our standard format. So min z is equal to 3x1 plus 5x2 subject to constraint number 1, x1 must be greater than or equal to 500. Constraint number 2, x2 must be greater than or equal to 200. And constraint number 3, 2x1 must be greater than or equal to x2. What we've done here is we've now taken our natural language question from here, practice example number 3. We've found the relevant information. We've written down the relevant information. And then we've collected all of the relevant information in one place in the correct universal format. It always has to be written in this format. From here, we can then, as we will do in the future, we can then solve using algebraic principles to determine our optimal choices for x1, the amount of chicken we include in a batch, and x2, the amount of beef we include in a batch. This is our wrap-up for lesson number 8, because what you are going to do now is you're going to solve practice example 1 and practice example 2. This information will be uploaded to our group chat. You are expected to solve it and answer the quiz accordingly to test for your comprehension. And it will be necessary to solve practice example 1 and practice example 2 in order to complete today's quiz. Hopefully everybody's clear on practice example 3. Your remaining tasks today are to solve practice example 1 and practice example 2. When we resume in lesson 9, we will discuss the correct answers for student practice example 1 and student practice example 2 before we move on. Thank you everyone for listening. Have a wonderful day, or enjoy your break before lesson 9, and I will see you shortly. Bye-bye.